Hi everyone, I am Dr. G. Sarojini, Associate Professor, Department of Chemical Engineering, Hindustan College of Engineering and Technology. In this video, I am going to discuss about refrigeration, which is a part of chemical engineering thermodynamics too. Refrigeration, it is a process of producing and maintaining a temperature below that of surrounding temperature. It finds wide application in chemical process industries. Refrigeration, it is used to remove heat of reaction and to liquefy process gas for gas separation by distillation and condensation. Refrigeration implies production of low temperature by continuously observing heat at a lower level and rejecting it to a higher level. So principle of refrigeration, actually heat cannot flow from low temperature to high temperature spontaneously. So external work is required to flow heat from low temperature to high temperature. So these external work is required for achieving refrigeration also. Thus the refrigeration is essentially an operation involving the pumping of heat from low temperature to high temperature. So two terms are used to represent the refrigeration. One is the coefficient of performance, another will be the refrigerator capacity. So coefficient of performance, it is generally mentioned as COP. It is defined as the quantity of heat absorbed at a low temperature per unit of work done. Then the refrigerator capacity, it determines the rate of circulation of the refrigerant. Usually the refrigerant capacity is measured in ton of refrigeration. 1 ton of refrigeration is defined as the heat absorption at the rate of 12,000 BTU per hour. So 1 ton of refrigeration, it is equal to the refrigeration of 12,660 kilojoule per hour. And then we are going to discuss what is refrigerator and refrigerant. So refrigerator, as I told, it is a reverse heat engine or a heat pump which takes out heat from a cold body and delivers it to a hot body. The refrigerant, it is a heat carrying medium during which the cycle in a refrigeration system absorbs heat from a low temperature system and delivers it to a high temperature system. And then we are going to discuss what are the components of refrigerator. So already we have told that refrigerator is a reversed heat engine and the heat flows from low temperature to high temperature. Actually, automatically the heat will not flow from low temperature to high temperature unless we provide some external work, right? So every type of refrigeration system used for producing cold must have the following four basic units, that is one low temperature thermal sink to which the heat is rejected for cooling the space, by means of which we extract the heat energy from the sink, raising its level of temperature before delivering it to heat reservoir. And next will be the reservoir. Reservoir is a storage to which the heat is transferred from the high temperature to high pressure refrigerant. So these are the components of refrigeration. That is the four changes of state will be occurring. One will be the expansion, another one will be the evaporation, and third one will be the compression, and fourth one will be the condensation. So this diagram, it shows the process of refrigeration. Actually, as we have discussed, there will be one evaporator, there is a refrigerator, and then compressor will be given. The price of the compressor chooses the rate of refrigeration, and then condenser and expansion valve. Here, if you take, so in the evaporator, just the refrigerant what we are passing will absorb the heat and then it will be changed into vapor. It will pass over to compressor. In the compressor, it will be compressed to, the vapor will be compressed to high pressure. Then the vapor will be passing over to condenser. From the condenser, the phase change occurs. The vapor gets phase changed to liquid. Then the liquid enters into the expansion valve. In the expansion valve, actually the pressure will be released. Whatever the pressure maintained inside the refrigerator will be reduced. Then it will be partially expanded. So the liquid plus vapor enters again the refrigerator and the cycle will be processed. So here the low pressure temperature refrigerant from the evaporator is drawn to the compressor through a inlet or suction valve where it is compressed to a high pressure and temperature. Then the high pressure and the temperature vapor refrigerant will be discharged into a condenser through a delivery or discharge valve. So in the condenser it consists of coils of pipe in which the high pressure and high temperature vapor refrigerant will be cooled and condenser. Then the refrigerant while passing through a condenser rejects its latent heat to surrounding condensing medium, which is normally air or water. Thus, the hot refrigerant vapor received from the compressor will be converted into liquid form in the condenser. So, receiver, the condensed liquid refrigerant from the condenser is stored in a vessel known as receiver, from where it is supplied to the expansion valve or refrigerant control valve. So here the expansion valve, its function is to allow the liquid refrigerant under high pressure and temperature to pass as the controlled lake after reducing its pressure and temperature. Some of the liquid refrigerant evaporates as it passes through the expansion valve, but the greater portion is vaporized in the evaporator at the low temperature and pressure. So evaporator, it consists of coils of pipes in which the liquid vapor refrigerant at low temperature and pressure will be evaporated and will be converted into vapor refrigerant at low pressure and temperature. So during low evaporation process, the liquid vapor refrigerant absorbs its latent heat of evaporation from the medium, which is to be cooled. So there are three stages of refrigeration. One will be your air refrigeration, and second one will be vapor compression, and third one will be the vapor adsorption refrigeration. So first, when we consider vapor compression refrigeration, this is the most important system from the point of commercialized and domestic utility and most practical form of refrigeration. Actually, the working fluid refrigerant used in this refrigeration system readily evaporates and condenses or changes alternatively between the vapor and the liquid phase without leaving the refrigerant plant. So during evaporation, it absorbs heat from the cold body, or in condensing or cooling, it rejects heat to the external hot body. The heat absorbed from the cold body during evaporation is used as its latent heat for converting it from liquid to vapor. Thus, the cooling effect is created in the fluid. So this is the working system of vapor compression refrigeration. As we have discussed, the evaporator will be having the coil, and there will be a receiver, and there will be a compressor, condenser, pressure gauge. The pressure gauge will measure the pressure. So this system of refrigeration that acts as a latent heat pump, since it is pumped from its latent heat from the cold body or brine and rejects it or deliver it to the external hot body or the cooling medium. So according to the law of thermodynamics, this can be done only on the expenditure of energy, which is supplied to the system in the form of electrical energy to drive the compressor. The vapor compression system, it is used in most of the modern refrigeration system in large scale industries, industrial plants. The vapor in this cycle is circulated through the various components of the system, where it undergoes a number of changes in its state or condition. So I hope this video will be helpful for you to learn how the refrigerator works and what are the components present inside the refrigerator. Thank you.